Have you ever thought about a secret language? One that's all around us, governing everything from a simple handmade quilt to the very architecture of the cosmos. Well, that language, it's mathematics.
Okay, so take a look at this quilt. I mean, at first glance, it's just beautiful, right? It's cozy. But if you really look closer, you start to see something else going on. You see these repeating shapes, these perfect angles, this amazing symmetry. Yeah, believe it or not, what you're actually looking at is math.
And it's this hidden language that connects, well, pretty much everything. It's like this fundamental code hiding right out in the open, linking the things we make with our own hands to the universe itself. So how about we start pulling on that thread and see where it leads?
All right, so our journey starts right here with the simple but really elegant logic of a quilt. So this technique is called patchwork, and really it's a system. You could even call it an algorithm. You just take these simple little pieces of fabric, follow a few basic rules, and you end up creating this incredibly complex and beautiful whole. And what's so cool about this is that quilters have been using geometry for centuries, a lot of them without ever taking a math class. They'll start with something simple, like a square. Maybe they arrange 9 of them into what's called a 9-patch block. Then, if you just slice that square in the diagonal, boom, you get 2 perfect triangles. And those simple shapes, they're the building blocks for just an almost endless variety of amazing, complex patterns. Okay, so we get it. Humans use these mathematical rules to create order and beauty. But what if I told you the universe has been playing by the exact same rulebook since, well, forever? And that brings us right into nature's own hidden code. I mean, just look at this broccoli. Seriously. See how the tiny little florets are just perfect miniature copies of the bigger stalk? Every little piece is a mirror image of the whole thing. It's the exact same idea we saw on the quilt, building something super complex from one simple repeating rule. You know, math actually has a name for this. It's called a fractal. The big idea here is something called self-similarity. It just means it's a pattern that repeats itself no matter how close you zoom in. You see it everywhere, in a tree branch, a coastline, even a river delta. And this is where math gets really cool and gives us a brand new language to describe all this complexity. Think about it, a simple line, that's one-dimensional, right? A flat square is two-dimensional. But what about a jagged fractal coastline? It's way more complex than just a line, but it doesn't really fill up a whole 2D space. So what is it? Well, math came up with something called fractal dimensions. It's basically a way to measure the roughness of these crazy shapes. It's a perfect example of how math is always growing to help us describe the world we see. Okay, so from the natural world, let's pivot to the digital one. This is a universe we literally built from the ground up, and its entire foundation is math. This machine right here, it's one of the most important inventions you've probably never even heard of. It's Herman Hollerith's tabulating machine. See, back in the late 1800s, the U.S. Census Bureau was just drowning in paper, drowning in data. Hollerith's machine was built to fix that. And the genius of it was how incredibly simple it was. Every single piece of information was just represented by a hole in a paper card. Either there was a hole or there wasn't. Punched, not punched. Yes, no. 1 or 0. That simple idea, that binary system, is the granddaddy of every single computer, every smartphone, all the software we use today. It all started right there.
And the impact? It was insane. Totally revolutionary. The 1890 census was finished in just 6 weeks. It saved the government a whopping $5 million, which was a fortune back then. And Hollerith's little company, built on his one simple math trick, yeah, it eventually became this tiny little startup you might know, IBM.
So, okay, we've seen how math is this language that describes patterns in everything from art to nature to tech. But it's not just for describing things. It's also an incredibly powerful tool for solving some of the most difficult puzzles you can imagine.
And sometimes, those puzzles are literally matters of life and death, where getting the right answer means everything.
Think about the tragic car crash in 1997 that killed Princess Diana. When it first happened, reports about how fast the car was going were all over the place. So what did investigators do? They turned to 3D computer animation, which is really just a bunch of geometry and physics, to piece together exactly what happened.
The math showed the car was going somewhere between 80 and 86 miles per hour. But here's the crucial part. It also simulated the forces inside the car, and what it revealed was that the impact itself was survivable. The conclusion, based purely on the math, was heartbreakingly clear. If she had been wearing a seatbelt, she almost certainly would have survived. And that kind of analytical power isn't just for accidents. It's huge in the world of forensics, where math helps investigators find the truth that's hidden in a crime scene.
A classic example, something called triangulation. It's pretty straightforward, really. By using some basic geometry, an analyst can take measurements from a few different spots to pinpoint the exact location of a person or a piece of evidence. It's a perfect example of how an abstract math idea becomes a real-world tool that delivers concrete answers.
All right, so far we've been talking about things we can see and measure. For this last part, let's get a little weird and jump into a concept that kind of defies measurement altogether: the idea of infinity.
You know, the whole concept of infinity has been messing with people's heads for thousands of years. Even one of the greatest mathematicians of all time, Carl Gauss, once said that using infinity was never permitted. The idea of something that just goes on forever, it just seemed too strange, too much of a paradox to fit into a system based on pure logic. But math grew up, it evolved, and now we get that infinity isn't some number you can count to. It's a concept. It's a way of describing something that's totally limitless, completely unbounded. And it's become this incredible tool that lets mathematicians explore everything from the true size of the universe to the very nature of numbers.
And that kind of brings us full circle, doesn't it? We started with the simple, humble pattern on a quilt, and we've ended up at the mind-bending idea of infinity. It just goes to show you that mathematics really is the universal language. It's the code that connects everything we see, everything we build, and everything we can possibly imagine. So I guess the only question left to ask is, what are we going to use it to translate next?